Hey there guys, Mr. Mises here, and I would like to talk to you guys about, hey, there I am. Hey, I would like to talk to you guys today about residuals and residual plots. So basically how to tell when one tells you good stuff and when one tells you not good stuff, and what do they tell us? Why do we use them? So let's go and take a look at, first of all, what a residual is, and then take a look at some residual plots and what it tells us. So a residual is the difference between the predicted value, which is the value that's going to be on our line from a regression equation. So I'm going to take a value, I'm going to plug it into my formula, my model, and I'm going to get my predicted value. Now that predicted value is going to be right around right there. Then I'm going to take my measured or my actual value that I found in my data, and I'm going to subtract the actual value from my I'm going to subtract my actual value and my predicted value. So if I want to say it the correct way, the predicted from the actual. Basically, remember this. The residual is the actual. So the value from my data minus my predicted value, which is what I got from my linear regression model. I take that difference and that gives me my residual. Now, I've got positive and negative residuals. A positive residual would mean that my actual value was up here above my predicted value, right? Because actual minus predicted is going to give me a positive value. Now, what that positive value tells me is that my actual was actually just larger than what I predicted it to be. In layman's terms, or in different terms, I underestimated what that should have been. So, it's just a prediction. So my prediction was an underestimate of what I actually should have gotten, the actual data, right? Now a negative residual would mean that the point is below the line, my regression line, meaning that my actual value was less than what I predicted it to be, or that I made an overestimate. What I could do is I could take all of these residuals and I could just, I could take a residual for this point and a residual for this point and a residual for this point and a residual for this point, find all of those residual values and plot them in their own plot versus the y value, and I will get a residual plot. So it'll do my own plot. Now, what does that residual plot tell me? Well, it tells me the hidden curve. So sometimes I might have my plots in my scatter plot line up and they look pretty nice, but there might be a curve in there that I don't really see in my scatter plot. If I draw a regression line, I might get an R. I might get an R of like 0.9. Well, the R tells me how strong the linear relationship is, but it doesn't tell me that if I create a linear model, is that linear model appropriate or not, based on my data, because the data might actually have a curve in there that I don't really see. So what I need to do is I need to take like a microscope and zoom into the scatter plot and then see if there's an actual curve in there. And the residual plot is that microscope that lets us look kind of deeper in our data to see if there might be a curve and if our linear model is appropriate. So what we're going to do is we're going to plot those residuals. And if we see a curve in my residual plot, it means that there's a curve in the actual data in the scatter plot that I didn't quite see, and that my linear model is not an appropriate equation to use for prediction. That's all it tells me, whether it's appropriate or not. The residual plot doesn't tell me how strong. It doesn't tell me how great of a predictor it is. It just tells me it's not appropriate. Okay? Now, a good residual plot is going to be nice and scattered, no pattern, little bit of residuals up above the zero, the horizontal, a few below the horizontal, nice and scattered out. So let me show you what those look like. So the one I have on the top is a nice looking residual. Notice they're kind of randomly scattered over. I've got some on top, some on bottom. There's no clear pattern. Whereas this one here on the corner, that one has a clear pattern, right? There's a curve. I can clearly see that there's a parabolic curve in this. That is a curved pattern. The residual in this case tells me that there's a curve in my data and my linear model is not appropriate. Remember that these residuals come from the linear equation. So this is just telling me, hey, your linear model is not appropriate for using as a predictive model because there's a curve in your data. And the residuals tell me that based on the curve in the residuals. So if I was to answer a question is, hey, how do I know if my linear model is appropriate? I know if my linear model is appropriate because one, I would see a curve in the data. Now, if I don't see a curve in the data, then I have to do part two, which would be to plot the residual plot. And the residual plot tells me, look, your linear model is not appropriate because of one of two things. Either the residual plot is curved, or the residual plot has variation that changes greatly from the beginning to the end. And let me show you what that looks like. So basically it's the fan out rule. So if I have a residual plot that fans out, all right, so notice these start really close and then they get further and further and further and further and further and further. So that means my residuals are getting bigger. That means what my scatter plot's going to kind of look like is it's going to be close to the line, and then eventually it's going to go really far away from the line. And that is not a good residual plot. That's not a good linear model because of those residuals changing so much. Now they could either fan out or they can also fan in. So I could have a bunch of residuals here and start to go towards the zero, right? So they can go like this and then fan in. So fanning in or fanning out, spreading in, spreading out, those are not good residual plots as well. Okay, so just to kind of summarize again, good residual plot, bad residual plot. What does the residual plot tell us? It tells us if our linear model is appropriate. That's it. It tells me if my linear model is appropriate. Shoo fly, don't bother me. Okay, we'll talk to you guys soon. Bye.